So let's look at how to linearize functions. So suppose f is a differentiable function at a point x equals a. Then for the values of x near a, the tangent line approximation to f of x is estimated to be f of a plus the derivative of f of a times x minus a. And we can say this is a local linearization of f near x equals a. And to represent this, the tangent line as a function, we're going to say that's equal to L of x. And f of x is an estimate to L of x, and that's going to equal the tangent line f of a plus f prime of a times x minus a. And I'll also do some examples to really understand what all this means. Question 1, we have the function f is twice differentiable where f of 3 equals negative 2, f prime of 3 equals 5, and f double prime of 3 equals 1. Write the equation of the tangent line and use the equation to find f of 3.1. So first, let's get our components. So we know that f of x is estimated to be L of x, which equals f of a plus the derivative of f of a times x minus a. So let's get all of these components to find the tangent line and f of 3.1. So first, f of a, we know that a is going to equal 3 because they gave us the point f of 3 equals negative 2. So we have 3 comma negative 2. So we know that a equals 3. And they also gave us f of a, which is negative 2. So f of a equals negative 2. And we also have f prime of a, which is 5. So now we have everything that we need to make our tangent line. So let's just do that. So L of x equals f of a, negative 2, plus the derivative of f of a, or the derivative of a, is 5, times x minus a, which is 3. So this is our tangent line at the point x equals 3. So now let's find f of 3.1. Since they tell us to use the equation of our tangent line, which is this right here, we can use L of x. So L of 3.1 equals negative 2 plus 5 times 3.1 minus 3. And this is going to equal, if you plug this into your calculator, or if you just manually solve this is going to equal negative 1.5. So now we can say the linearization of f of x at a equals 3 is negative 1.5. Question 2, we have find the linearization of the function f of x equals square root x at x equals 4. Then find the value of f of 3.99 using the equation, and state if it is an under or overestimate. So this time we have to do the same thing, except we have to find the values ourselves. So let's state that f of x is estimated to be L of x, which equals f of a plus the derivative of a times x minus a. So now we have a to be 4, which is given to us, f of a. So if we plug in 4 into square root x, it's going to be 2. And the derivative of a is going to be, so let's just find it over here. So the derivative of f prime of x is just going to be 1 over 2 square root x. So if we plug in 4 into here, this is just going to turn out to be 1 over 4. So now let's find L of x. We already have it. Let's just plug it into the components. L of x equals 2 plus f prime of a is 1 over 4 times x minus 4. So this is our tangent line. So let's circle that. And now let's find the value of f of 3.99. So L of 3.99, this is going to equal 2 plus 1 over 4 times 3.99 minus 4. And this is going to turn out to be, if you plug into your calculator, this is going to be 1.9975. Okay, now we have to see if this is an underestimate or an overestimate. So let's just circle this because this is our approximation. And to do this, we're going to go back to our original function and find the second derivative. So this is the first derivative. We need to find the second derivative. So f double prime of x is going to equal negative 1 over 4x to the 3 over 2. Now, if we plug in f double prime of what we're trying to approximate, 3.99, and once again, if you plug this into your calculator, you're just going to get negative 0.0313, something close to that. Now, we see that this value is less than 0. If the second derivative, if the value of a at the second derivative is less than 0, then we can say this is a overestimate. And it also goes vice versa. If the value of the second derivative at a is greater than 0, then it's going to be an underestimate. And that's because when f double prime of x is greater than 0, the concavity is up, and the tangent line is going to be below the graph. But if the second derivative is less than 0, in this case, the concavity is going to be down, and the tangent line is going to be above the second derivative, so it's going to be an overestimate. Question 3, we have, find the linearization of the function f of x equals sine x at x equals pi over 3, then find the value of f of 1.05 and state if it is an over or underestimate. So let's say, once again, f of x and then L of x equals f of a plus the derivative of a times x minus a. So a we have to be pi over 3, and f of a is sine pi over 3, and that's going to be root 3 over 2. And f prime of a, so let's just find that real quick. So f prime of x is actually equal to cosine x, because that's the derivative of sine x. So f prime of a is going to equal 1 over 2. So now let's write our L of x. This is going to equal root 3 over 2 plus 1 over 2 times x minus pi over 3. And this is our L of x. Now let's find f of 1.05. So let's plug into our L of x equation. L of 1.05 is going to equal square root 3 over 2 plus 1 over 2 times 1.05 minus pi over 3 is going to equal roughly around 0.867. Now this is our approximation for f of 1.05, but now let's see if it's an overestimate or underestimate. To find that, let's find the second derivative. So we have to find the derivative of cosine x. So the derivative of cosine x is going to equal negative sine x. So if we plug f double prime of 1.05 into negative sine x, we're going to get negative 0.867. There's more numbers, but we can just round it to just 3 sig figs. So again, this is negative, which is less than 0. So that means the approximation is going to be an overestimate again. And these are our final answers.